So good day everyone. We are here today to know the Excel program for flexural and rigid pavements that I've made. So ito yung Excel program na ginawa ko. So this is for the flexural pavement and the other sheet is for the rigid pavement. So dito sa flexural pavement, by the way, I use the AH2 specifications for the computations for the SL, SN, and the thickness. Alright. So, dito sa loob ng Excel, nandito yung instructions, yung video link for my video tutorial. Then, the legends and formulas that I use dito sa SL, which is equal to FD times GJ times AADT times 365 times N times F, where SL is the equivalent accumulated 18,000 lb or 80 kilonewton single axle load for the axle category. Now the FD here is the design lane factor. The GJ is the growth factor for a given growth rate R and design period N. So the AADT is the first year annual average daily traffic for axle category. Then your N here is the number of axle on each vehicle in category. And the F is the load equivalency factor for axle category. Now, the second equation that I use is this. Sn is equal to A1 times D1 plus A2 times D2 times M2 plus A3 times D3 times M3, where Sn is the flexural pavement structural number. The Mi is the drainage coefficient for layer I. The A1, A2, and A3 are the layer of coefficients representative of surface, base, and sub-base cores respectively. So lastly, the D1, D2, and D3 is the actual thickness in inches of surface, base, and sub-base cores respectively. Now the last formula that I use is this log 10 W18 or your SL is equal to ZR times S plus 9.36 log 10 of NSN plus 1 minus 0.20 plus log 10 of dpsi over 4.2 minus 1.5 all over 0.40 plus 1094 over Sn plus 1 raised to the power of 5.19 plus 2.32 log 10 of Mr minus 8.07, where W18 is your predicted number of 18,000 lb or 80 kilonewton single axle load applications, or basically your SL. Now the ZR here is the standard normal deviation for a given reliability. S is your overall standard deviation. Your Sn is your structural number indicative of the total pavement thickness. Your dpsi is the difference between the initial serviceability and the terminal serviceability index. Now, your PO here is your initial, and your PT is the terminal serviceability index. And last, your MR or your resilience of modulus of the roadbed soil. Also, nandito rin yung suggested values for reliability, for serviceability. This is yung ano mo, yung layer of coefficients mo. Ito. Tapos suggested resilience or subgrade resilience or your MR, your minimum thickness for your highway layers, and lastly, your drainage coefficient. So, ito yung first part. Tapos, ito yung computations for SL, yung input values, computation, and output values. Also, dito rin yung computation for provided and required SN, the computation, and the outputs. And lastly, you have the computation for thickness and your new SN, the computation, and the output values. Also, you have here your visual representations of the cross-sectional area of your road. Now, before you use this Excel, you must install first the solver add-in so that you can solve the value of your Sn. So, how to install the solver add-in, just click the file, go to options, and then go to add-ins. Go to this manage Excel add-ins. Let's click go, and then check this box, solver add-in, then click OK. Then for you to check if the solver is already in your Excel, just click this data, and under analysis there is a solver. So it means that it is installed already. Then for us to know if these computations are working, let's have an example. So I have a problem here of a given data of AADT of 12,000. So let's change that into 12,000. Next is your two-axle single unit trucks, 33%. Or your two-axle category, 0.33. Next is your three-axle category, which is 0.17. Then after that, you have a given of growth factor, which is 29.78. 29.78. Then you have the percent truck volume on design lane, which is 45%, so 0.45. Then you have your two axle factor, which is 0.010. And last, your three axle factor, which is 0.088. And so you will have your values, the computations first. So for the SL or the single axle, you have 45.45 times your GJ 29.78 times your AADT, which is 12,000, and times 365. So you have a value of 0.160812 times 10 raised to the power of 6 psi, means it's in the million. So in the set two axle category, you have 0.45 times your 29.78 times 12,000 times 0.33 times 2 times 365 times 0.01, and your three axle category is 0.45, 2.79, 12,000, 0.17, 3, 365, and 0.088. And so you have the value of this. So your total SL is equal to the second two axle category plus the three axle category. So if you don't have any values for your two axle category, let's change it to 0. So your total SL will become the SL of the single axle, which is 0.160812. So that's it for the computation for SL. Now let's try to use this computation for provided and required SN. So here again, we have a problem. So we have a given of reliability of 99%, your SL of 2 million, your standard deviation of 0.49, your subgrade is 6 times 1,500, which is 9,000. Then your serviceability, given in siya 4.5, your PT 2.5. So if you don't have any values for these inputs, you can refer to the suggested values. Ito, dito. So next is ito na. So ito yung formula, di ba? Log 10 of your SL is equal to your ZR, which derived from your reliability, times the S or your standard deviation plus 9.36 times log 10 of your SN plus 1. So my SN here is have initial value of 4.2690. So let's try on changing it to 0. So 0 yan siya. Alright. So plus 1 plus the log 10 of your DPSI. So ito yung DPSI, computation for DPSI. PO minus PT. So may value siya na 2 over 4.2 minus 1.5 all over 0.4 plus 109 all over over your SN plus 1 raised to the power of 5.19, and then plus 2.32 times log of your MR minus 8.07. And so we will have your value. If you click on data, click the solver, and then click solve, click OK. And so your SN will become 4.20. Right? And so you can input that value here, which is the SN3, 4.327. Then let's try and changing the value of your MR into the CBR value of your course material, which is 13,500. And so click the solver, solve, and okay. So you will have your SN2 worth 3.71. Here, 3.71. And then lastly, for your SN1, change the value of your MR into 31,000 for your base course material. Click the solve and solve, then okay. And so you will have the value of 2.775. 2.75. So 2.75. And so if you don't have any values for your layer coefficient and your drainage coefficient, let's check here in suggested values. So nandito yung layer coefficient. So if your layer coefficient for asphalt is this 414 and 416 mixes, you use this 0.44. If you use 411 mixes, use this 0.31. And then sa base layer coefficient mo, pag granular base, 0.14. Pag bituminous, 0.30. And pag cement or lime treated base, 0.23. And lastly, your sub-base layer coefficient for your granular base, sub-base is 0.11. So I will use value of 0.44, 0.14, and 0.11. Okay. So here, put this 0.44 for your base, 0.14, and your sub-base, 0.11. And here in the given problem, we have a drainage coefficient worth 0.8. And so we will have these values for computation. So first, we will solve the D1. So for us to solve the D1, it's just your SN over your layer of coefficient for the surface. So we have the value of your SNU, which is 8 times 0.44 based from the surface or the output values of your surface thickness. Then after that, you will solve for the D2. D2 is equal to your SN2 over your base times your drainage coefficient. So then after that, if you get the value, so 4, we can solve now for the SN2 new, which is your thickness times your layer coefficient times your drainage coefficient, which is 3.968. Then last is your D3, which is equal to your SN3 over layer coefficient of your subbase times the drainage coefficient of your subbase. So you have a value of 4. And so we can solve for our SN3 new, which is your thickness times your layer coefficient times your drainage coefficient. Then after that, you can see the visual representation of your cross-sectional area of your road here. So you have a surface course of 8, base course of 4, and sub-base course of 4 inches in thickness. So ito yun. So for us to know if these values are adequate or insufficient, we can input all of these values here. So I have a surface thickness of 8, layer coefficient of 44.44, base thickness of 4. I have a layer coefficient of 0.14, finish coefficient of 0.8, so base again 4, and then 0.11, and then 0.8. And so we can see here, let's change the values of our MR into 9,000 again so that we'll solve for our SN. Dissolver, solve, and okay. And so we can see here that the values are adequate. And so we can use these values for our design of pavement. Alright? So ito na yung design ng pavement mo. Okay? So that's all, I guess, for the flexural pavement. Let's go to the rigid pavements now. So again, here sa rigid pavements, nandito yung instructions. And also, I use H2 specifications again for rigid pavements. Next is the suggested values here, the reliability, your K values, or your modulus of subgrade reaction, your J factor, or your load transfer coefficient, serviceability, drainage coefficient, standard deviation, elastic modulus, and your modulus of rupture. So here, we have a legends and formula of log 10 of W18 or your SL is equal to ZR times S plus 7.35 times the log of your thickness or D plus 1 minus 0.06 plus log 10 of DPSI over 4.5 minus 1.5 all over 1 plus 1.624 times 10 raised to the power of 7 all over D plus 1 raised to the power 8.46 plus 4.2 minus 0.32 times your initial or your terminal serviceability index times the log 10 of your SC or your modulus of rupture, your coefficient, drainage coefficient, your times your thickness raised to the power of 0.75 minus 1.132 all over 215.63 times your load transfer coefficient times your thickness raised to the power of 0.75 minus 18.42 all over EC or your elastic modulus over your modulus of subgrade reaction raised to the power of 0.25. Note that here in the computation for rigid pavement, your JPCP is always 15 feet or 4.6 meters and your JRCP is 40 feet or 12.2 meters. It's based on the AH2 specifications of the spacing for your joints. So here, let's try to compute for the thickness since there is not much any problems in rigid pavements. So I have here values prepared. So I have a value of W18 or my SL is 2 million. I have a reliability of 99%, standard deviation of 0.49, elastic modulus of 4,500,000. So if I don't have any values, I can just refer here to suggested values. So if I use the elastic modulus of 4,500,000, so I can use this modulus of fracture of 705. So here, modulus of fracture 705, drainage coefficient from 0.8, the lowest, and 1.2 as the highest. So if you don't have any values, you can just put 1. Load transfer J. Here you can see you if your pavement is on dowel PCC on crush aggregate surface, dowel PCC on HMA, CRCP with HMA, and CRCP with tight PCC, so shoulders. So I want to use this dowel PCC on HMA, so 2.7. Subgrade reaction of K, let's see, 84. Serviceability index, initial 4.5, then 2.5 for the terminal. And so after that, we have this computation for DPSI again. It's initial minus the terminal. And the log of your SL, 2 million, minus your ZR, based from your reliability, times your S, or standard deviation, plus 7.35, times the log 10 of your D, your thickness, plus 1 minus 0.06, plus log of your DPSI over 4.5 minus 1.5 all over 1 plus 1624 times 10 raised to the power of 7 over your D plus 1 raised to the power of 8.46 plus 4.22 minus 0.32 times 2.5 times log of this, your 705, your rupture modulus, your coefficient, drainage coefficient 1, your D again here, raised to the power of 0.75 minus 1.132 all over 215.63 times 2.7 times 0, or your D thickness, raised to the power of 0.75 minus 18.42 all over your E, or your elastic modulus, over your K, or your subgrade reaction, raised to the power of 0.25. And so, before you click this over, make sure that you input a value of initial value of your thickness. Let's put value of 5. And so, you can click this over. So, click OK. So, you have a value of thickness of 9. So, in order to be safe, your value of thickness is 10 inch and your sub-base thickness is 6 inch. Now, your sub-base thickness will differ based on your SL. So that's it. So you can see for the visual representation of your cross-sectional area. Here you have the concrete surface of 10 inches and the sub-base course of 6 inches. And I guess that's all. So thank you for watching.